So on proofs, you really only start knowing two things. You know what you are given, and here we are given this sentence and we're given the picture, and we know what we have to prove. Right here, DE is parallel to GF. All right, so we start with writing down our givens. So anything that's after the word given are your givens. So angle 1 is congruent to angle 2, and angle 1 is congruent to angle 4. That was given. Then in the last box, go ahead and write down what you were supposed to prove. I'm supposed to prove that DE is parallel to GF. So you already can fill in those boxes just based on what you were given in the beginning. So then once you wrote down all the things you need to write down, the stuff that you were given, then you go back to your picture and you mark it. Angle 1 is congruent to angle 2, so I'm putting these arc marks there. Now, these angles don't look congruent, but picture is not drawn to scale. You can never make assumptions based on the scaleness of that picture. And then angle 1 is congruent to angle 4. So those arc marks show that all these angles are congruent. Okay? Now, knowing that I need to prove, I haven't proved it yet, but I need to prove that DE is parallel to GF. And then those lines are cut by this transversal right here, right? So just looking at how I marked the picture, I can already tell that, oh, these two lines, I'm going to be able to prove that they are congruent, that they are parallel because these two angles are congruent. Because here we have alternate interior angles. They make this Z shape, alternate interior angles. So I already know why it's congruent. It's congruent because angle 2 is congruent to angle 4. And we know that these are parallel because those make alternate interior angles. So alternate interior angles. So we're stuck. We have a section in our proof that we're like, well, what goes here? We know they're parallel because alternate interior angles. We know these two are congruent, but wait, how do we know they're congruent? We know based on the picture, but we can't just say because of the picture. Instead, we have to look back at our givens and be like, how do we get from here to here? Well, if I highlight this, I can see my 1, my 2, and here's my 4. I can easily see that angle 1 is congruent to angle 2, and angle 1 is congruent to angle 4. Well, then if this is congruent to that, and this is the same thing is congruent to that, then won't these two be congruent as well? Well, that's a roundabout substitution that is called the transitive property. And the way the transitive property works is when you have a substitution where you have your 3 colors and you can eliminate one of them by setting these two things equal to each other or congruent to each other, then that is the transitive property. All right, so from now on, anytime you're dealing with some kind of a substitution, transitive property is a type of substitution, highlight what you're substituting. If you end up having 3 colors like this where one of the colors gets eliminated because you can set these two congruent to each other, okay, then that you're using the transitive property. All right, so moving on. This next proof, much longer. First thing, what are our givens? Line M is perpendicular. That upside down T means perpendicular. So line M is perpendicular to N. So I'm going to go ahead and put a right angle thing here because if they're perpendicular, then we have a right angle. Okay? And 3 and 4 are complementary. So 3 and 4, there's no way I can mark it, but I'm going to have to write something about it in my proof eventually. And then it says prove angle 5 is congruent to angle 6. So all the way at the bottom of my proof, I'm going to go ahead and write angle 5 is congruent to angle 6. I don't know why yet, but I know that that's the last thing that needs to be in my proof. Okay, so the first thing was given to us. I can go back and check, like, all of that is in my givens, and all my givens are written right there. Okay. Next, we have measure of angle 3 plus measure of angle 6. Oh, measure 3, 6, they're right here. It says it is a right angle. Why is it a right angle? Well, why did I draw this? I drew that because I said M is perpendicular to N. And because it's perpendicular, we have a right angle. So I'm using my definition of perpendicular to do that. So definition of perpendicular. Okay. And then now I need to go ahead and turn this right angle into an actual number. What number should that be? Well, it should be 90 degrees. So now I have measure of angle 3 plus measure of angle 6 is equal to 90 degrees. Okay, so that is why? Because right angle is 90 degrees. So that is a definition of right angle that I'm using. Okay, next we have measure of angle 3 plus measure of angle 4 is 90 degrees. Nothing in my picture tells me that they're 90 degrees. Is there anything else that tells me that they're 90 degrees? Well, if I go all the way back to my givens, my given was that they were complementary. Well, what does complementary mean? Complementary means adds up to 90 degrees. So I am using definition of complementary that was in my givens. All right, so done there. All right, now we have all of these things are equal to each other. How do we know? Well, we've got a 90 degrees here, and we've got a 90 degrees here, and then we've got this part is right there, and we've got this part is right here. Now, isn't that what I said earlier for transitive property, where if this part is equal to that and this part is also equal to that, then we can eliminate that piece and just set these two things equal to each other? That is transitive property right there. You see how with the highlighters it's easy to recognize transitive property? I can eliminate a color by setting these two equal to each other because they're both equal to the same thing. All right, next, from here to here, how do I get there? What changed? Well, if I look at this equation closely, I see a measure of angle 3 here, and I see a measure of angle 3 here. But everything else looks the same for both this top equation and here. Well, measure of angle 3 got removed from both sides. What is it called when something gets removed from both sides? That is the subtraction property. Oops, I can't spell. That is the subtraction property. Okay, so you removed those. Okay, next, from here to here, what changed? Well, the measure went away, the equal sign changed to a congruent sign. Equal changing to a congruent sign, that is definition of congruent. Okay, and now I have to find a way to get from angle 6 is congruent to angle 4, so I'm going to go ahead and start marking my picture for what I put in this proof. Angle 6 is congruent to angle 4. I have to get from here to say that angle 5 is congruent to angle 6. How can I get from here to getting somehow to angle 5? Well, if I look at my picture closely, I can see that angle 4 and angle 5 should be congruent. Why? What kind of angle pairing is that? Well, that is vertical angles. So angle 5 should be congruent to angle 4 because of vertical angles. Okay, and I'm going to go ahead and mark it on my picture now that I said that. So we got that because of vertical angles, and then the last thing we say is, oh, angle 6 is congruent to angle 5. Well, our picture says that. Now, how do we get on our proof to say that? Well, how do we get from here to here? Well, there's no easy way to get from here to here. How do can you just replace the 4 and 6? Ah, yes, you can replace the 4 and 6 because our 6 is right here. Our 6 is right here. Let's see if we have transitive property or substitution. Highlighters will let you know. If we have the same highlighter marks here, okay, so this is another example of transitive property because I have the same 3 highlighter marks, but I was able to eliminate this blue highlighter mark by setting everything equal to each other or congruent to each other in this case. All right, so this is another example of transitive property. On this next example, we have all of our givens are already written. There's nothing I can mark in my picture. My picture is marked, okay? But the last thing, it tells me I need to prove this U is parallel to V. I still don't know why, but there's that. Okay, so now let's examine our givens. First of all, these look like division signs. They're plus signs. Well, that's a minus, okay? Okay, so I have my x is given, all right? So how do I prove that these two lines are parallel? All right, because that's what it's telling me to do. Well, if I can prove that these two lines add up to 180, because right there, if they are parallel, then these are consecutive interior angles. If I can prove that they add up to 180, then I can prove that they're parallel. So first I need to figure out what each of these angles actually is equal to. So I'll start with angle 1. All right, so I have measure of angle 1 is equal to 10, and I said 10x. Well, I know what x is. X is 6, so 10 times 6 plus 10. All right, and what is it called when I'm just replacing a single number? That is substitution. All right, and then after that, I'm going to do the same thing with measure of angle 2. So measure of angle 2 is equal to 19 times, instead of x, I'm going to put my 6. Oops, it's minus 4. Okay, again, we're just substituting in our x. And then, now that I put that, let's figure out what they actually equal. Measure of angle 1 is equal to, let's see, 10 times 6 is 60, plus 10, that's 70. And all I did there was solve, so that is called simplify. Or combining like terms, it's the same thing, okay? So simplifying, combining like terms is the same thing. All right, measure of angle 2, 19 times 6, minus 4, that's 110 degrees. Simplify again. All right, now from here, yeah, I can see that these two add up to 180, so let me go ahead and write that my measure of angle 1 plus my measure of angle 2 is equal to 180. What reason code can I possibly use to say that, though? Mathematically it makes sense, but how can I say it in some other way? Well, we have up here 70 plus 110 equals 180 as one of the givens. So all I did was substitute in my measure of angle 1, and I substituted in my measure of angle 2 over there. So that is substitution. And some of you might be like, whoa, is it substitution or transitive property? Because I feel like you just substituted twice. Well, here's my 70, that's one color. Okay. and here's my blue. That's the other color that I'm substituting. All right. Here's my orange. I'm substituting orange goes right here, and here's my green. Okay. And you might be like, oh, yeah, we eliminated some colors. We totally eliminated yellow and green. That's not how transitive property works. Transitive property works by eliminating a single color, not two colors. All right? So all you did was, you're like, oh, yellow equals blue. Therefore, we have blue. All right? We have yellow plus green, and now we have blue plus orange. Okay? Because we just substituted one step. Okay? We did not eliminate a single color. So it's still just substitution property. Okay? And so now that we know that these two equal 180, when they added up, they're equal to 180. What does that mean? Well, it means that they are supplementary. So we have angle 1 and angle 2 are supplementary. And that is definition of supplementary. And you're like, why did I take that step? And the reason why is because the actual proof, the actual wordage for the consecutive interior angle property, or consecutive interior angle theorem, the actual wordage says if angle 1 and angle 2 are supplementary, then you have parallel lines. So we have to, even though we know like, oh, they're adding up to 180, that means supplementary, we still have to have a step in our proof saying supplementary before we say the word parallel, because we have to link it back to the actual words in the consecutive interior angle theorem. All right, so these are consecutive interior angles, right? So that's what we were using to prove parallel, okay? Moving on. This last one, very similar to what we just did, all right? It's just asking us to prove, again, that U is parallel to V. And looking at the picture, if U and V are parallel, then why are they parallel? Well, because this angle is congruent to that angle, and if those angles are congruent, then we have, we're using corresponding angle theorem. These are corresponding angles, okay? So we have to find a way to prove these two angles congruent. So let's go ahead and start with that. We have measure of angle 1 is 85 given. I can't do anything more with that. But measure of angle 2, they did not give me an actual angle measure. Instead, they gave me 15x minus 5. So instead, I want to figure out what that measure is. So I'm given x. My x is 6 again. All right, so all I did was substitute in my 6 for my x. Okay, and then next, what is that equal to? Measure of angle 2 is equal to, that is 85. Okay, so all I did there was simplify. And we have measure of angle 2 is 85, measure of angle 1 is 85. Oh, if they're both equal to 85, then I can set one of them equal to the other one. Now, the next thing I got to do is figure out, am I using substitution or am I using transitive property? Now, you're new to using transitive property, so some of you guys might be like, I do not get this transitive property substitution thing. Well, if you can recognize that it's a type of substitution, that's good for now. Okay, so for now, just think about, oh, it is a type of substitution. But right here, I am clarifying, is it transitive or is it just regular old substitution? Well, we have orange equals green, orange equals yellow, green equals yellow, therefore orange equals green. That is a type of transitive property because we were able to eliminate this yellow by setting these two equal to each other because they equal the same thing. So that is transitive property. All right, and last step, okay, you might be like, oh, they're equal to each other, we've got corresponding angles. No, the wording in the actual theorem says congruent, not equal. So we have to take a step to be like angle 1 is congruent to angle 2. Why? We're using definition of congruent to get rid of that equal sign and turn it into a congruent sign. Now, this properly satisfies the wording in the theorem that says corresponding angles are parallel. So we got they're parallel because of corresponding angles.